Hello all, my name is Patel and in next 15 to 20 minutes I'm going to talk about cybersecurity in cloud. More specifically on infrastructure as a service side, also written as IaaS. The reason I chose this topic was because cloud computing has been evolving greatly in all different sizes of companies and also in our personal life. Most applications we use are on cloud, for example, emails and iCloud for Apple users. Infrastructure as service being the base of cloud computing, there are many security concerns and threats related to it. In this PowerPoint, I'm going to talk about cybersecurity and how that relates to infrastructure as service. Secondly, I'm going to give brief introduction on different types of cloud, which are private and public cloud. Then I'm going to talk about list of security concerns related to cloud service and solutions for it. Due to this topic limitations, I'm not going to talk about benefits of infrastructure as service or other cloud services. So, what is cybersecurity? It refers to the body of technologies, processes, and practices designed to protect networks, devices, programs, and data from attack, damages, and unauthorized access. In other words, it is information technology security. We are going to talk more about cybersecurity in respect to infrastructure as service later in this PowerPoint. So, what is infrastructure as service? It is one of the three services in cloud computing. The other two are platform as service and software as service. Here, the cloud computing sort of sharing computing resources rather than having local servers or personal devices to handle applications. The word cloud can be thought of it as the internet, and the whole term can be known simply as internet-based computing, where services like servers, storage, and application are given to an organization through the internet. These servers and resources can be located anywhere geographically. So, going back to infrastructure as service, what it is. Its consumer can rent all possible IT resources as storage, data center, operating system, firewalls, load balancer, and more without worrying about hardware requirements and infrastructure. Some service providers are Amazon Web Services, Google Compute Engine, Windows Azure, IBM Smart Cloud, Rackspace Open Cloud, and many more. This slide talks about two main type of clouds that IaaS can be implemented on: public cloud and private cloud. Public clouds are available to public by cloud service provider who is responsible for its security and availability. For example, Google Computing Engine, Amazon AWS, Microsoft Azure can have public resources that anyone can use with certain price. Having your data stored in third-party storage or using their hardware doesn't sound safe. However, continuous hacks attempts have hardened the security. We're going to talk more about security concerns and prevention in next few slides. On the other hand side, private cloud is infrastructure dedicated to one organization, meaning it's not shared with other organizations. They are expensive but more secure than public clouds because you have control over it. There are security concerns related to infrastructure as service. Few are data leakage protection and usage monitoring, authentication and authorization, logging and reporting, end-to-end encryption, external network attacks, service level agreement SLA, service availability, and cloud service alliance CSA. Data stored in cloud should be kept confidential. It means that only authorized users should have access to the data. This is a main concern when deploying infrastructure as service in a public cloud. These issues can be resolved by up-to-date managing services by restricting the data uses. Also, the uses should be monitored continuously. Maybe create transparent process that controls who can see the information, and then create a self-destruct policy for sensitive information. Knowing the data and how it's used by the provider is important. In 2016, Dropbox data breach occurred and 26 million users' account information were leaked. Who knows, you might be one of them. Authentication and authorization is another main issue. It is one of the most common security measures a system has to maintain. Having a username and password is not enough for high security. A service provider should also use other sort of authentication. For example, asking for best childhood friend's name or a spouse name. In 2016, hackers leaked millions of usernames and passwords for emails. These kind of leaks happens every day around the world. However, with better protective measures, you can reduce the chance of happening. Third, logging and reporting. To make deployment of IaaS more effective, logging and reporting should be used effectively. With a good logging and reporting, we can track the information, its user, machine which is handling the jobs, and storage where the informations are stored, especially after an incident has occurred. End-to-end encryption is important for public and private IaaS. Encryption is basically converting information or data into some type of code. Since your data is stored in cloud, you need to prevent any kind of weaknesses. Here, we can use whole disk encryption or anything on less IaaS, including VMs and operating system, needs to be encrypted for security measures. TrueCrypt and Discryptor are tools you can use to do full disk encryption. For Mac users, with FileVault, you can perform similar encryption. Next is the external attacks. Infrastructure as service operates through network and internet connectivity. Issues like man-in-the-middle attack and flooding attack needs preventative measures. Man-in-the-middle attack is when a hacker changes the network connectivity by creating middleman addressing. So it feels like two parties are communicating directly to each other. For example, changing the network name to the network an individual is trying to access. As you can see in the top right picture, user is connected to man in the middle, and similar web application is connected to man in the middle. However, they are not aware of this connection. DDoS, also known as distributed denial of service attack, is another attack, as many of you already know about it. This attack is an attempt to make the online service unavailable by flooding the targeted system with traffic. IP snooping and port scanning are other issues which cloud faces because it is tied with internet in general. When you are connected with internet, a lot of these issues will be encountered. Implementing firewall rules to control the traffic based on source IP address can reduce the risk of network related issues and attacks. Another concern is the service level agreement, SLA. SLA is a contract between the service provider and client to make the trust of quality of services and guarantee of time. To monitor SLA, Web Service Level Agreement framework is designed. This framework manages SLA trust. We can also say that it is created so that service providers guarantee better service to client. This slide talks about more security and concerns. So in cloud, the availability only applied to infrastructure because it is the platform as service and software as service are dependent on the infrastructure. Therefore, guarantee uptime is important for infrastructure as service. There is no 100% in achieving continuous service. There could be a disaster or power outage or break in fiber optics which can bring down the infrastructure as service. And in 2012, entire data center which was owned by Amazon was knocked by storm. Its client like Instagram, Netflix, Pinterest were down for more than 6 hours. Research shows that since 2007, about 568 hours were logged as a downtime between 13 major cloud carriers. A week ago, the company I work for had fiber optic cuts, so we could not access any of the servers or files for almost 12 hours. Frequent data backup is important in any case of data in case any data gets corrupted due to this. Besides these, there are controls created by Cloud Service Alliance for better security cloud. These are implemented to make cloud security architecture effective. First is deterrent control, which reduce attacks by informing potential attackers. Preventative controls, which strengthens the system against incident by reducing weaknesses. Detective controls detects and reacts by sending signals to preventative or corrective controls. And last, corrective control, which reduces consequences of an incident by limiting the damage. So, in conclusion, as the last slide, this table briefly mentions the threats and solutions related to IaaS. To reduce DDoS attack, set up rules in firewalls. To reduce man-in-the-middle attack, have traffic encryption implemented. IP snooping can be lowered by network monitoring. To confirm if cloud provider is agreeing with SLA, use web service level agreement to get the trust. Physical attack is something I did not mention in the PowerPoint. However, it is something to keep a note on. High security locks rooms with monitoring is needed to protect against this physical attacks. Authentication leaks can be controlled by strong password and multiple layer authentication. Transparency and monitoring is needed to know the data leaks and prevent them. So Sanders' law said any person can invent a security system so clever that she or he cannot think of how to break it. Cloud computing has speedily increased over decade, but still there are concerns over security measures. No matter how secure your informations are, there is someone who will try to break it and eventually succeed. However, follow rules and protective measures to reduce the chance of being hacked. And this is it from my side. These are some works cited which I used to make this PowerPoint, and that's it. Thank you for listening.